we're going to go over operations on radicals today. So we talked about radicals and how they're just these square roots. Now we're going to go through operations, aka we're going to ask some questions about them, what happens when we add them and subtract them, multiply and divide, and see what happens. So our goal is simple. It's just to be able to perform operations on radicals. So as long as we can do that, we're in good shape. Let's go over addition and subtraction. So for addition and subtraction, there is a rule. There's a rule, there's like a stipulation, and that it's that they have to have the same radicand. So the thing underneath that square root sign has to be the same. What you're going to do is you're going to add them up just like a regular old thing, like in monomial. And when you do this, you want to think like terms. So when we're adding monomials, what happened is you would say 3x plus 4x. Well, 3 plus 4 is 7. The x stays the same, so you'd end up with 7x. Same thing with these radicals. Let's do an example. Let's actually do two of them. So we have 2 square root of 3 plus 6 square root of 3. So the first thing that we have to do is make sure that these actually have the same radicand. So you have that radicand of 3 and 3. Since they have the same one, we can go ahead and add them. What we're going to do is we're going to add the coefficients. So 2 plus 6 is 8. The square root of 3 is going to stay the same because it's just like when we were adding monomials in like terms, that the variable didn't actually do anything, but the coefficient in front of the variable is what we're adding in subtraction. So we end up with 8 square root of 3. That's our answer. Really nice and easy. Let's do it again on this one. We have 3 square root of 5 minus 2 square root of 5. So now we're subtracting. Do they have the same radicand? Well, we have one radicand here, one radicand here. They're both 5, so we're okay with that. What we're going to do now is we're going to do 3 minus 2, or you can think of it as 3 plus a negative 2. 3 minus 2 is easier. So 3 minus 2 is 1, so we're going to be left with a 1 out front, square root of 5. Now, we can just write that as square root of 5. No big deal. The 1 is just there so that we can know, yeah, we subtracted these things. Now, there's another thing as well. With this addition and subtraction, sometime we need to simplify the radicands, or the radicals, before we can add them. So go back to our 1.6 where we were talking about simplifying. Addition and subtraction that seemed impossible when they had different things under the root actually becomes possible. Well, not all the time, but sometimes will become possible when we simplify. Let's take a look at this. We have 4 root 12 plus 6 root 3 minus 27, or square root of 27. 12, we can split that into 2. Let's actually do 4 and 3 because 4 splits into 2 and 2. 27, well, that can split into 3 and 9. 9 can split into 3 and 3. So what we actually have here is we'll pull that out. So we have 2 times 4, so these 2's times that 4 gives us an 8. Screw it, what's left over? The 3. Plus 6 square root of 3. There's nothing going on there, we can't do anything. And we're going to subtract, we have that 3 in there, so we can pull those ones out. 3 square root of 3. So now we have 8 square root of 3 plus 3, or 6 square root of 3 minus 3 square root of 3. Well, 8 plus 6 is 14. 14 minus 3 is 11, so we end up with 11 square root of 3. So we can find an answer to this even though looking at it at the beginning, it didn't look like we could do anything. But because we simplified, we were actually able to add and subtract them. So here's our quick check. We want to add the radicals and subtract them. If we can't do it, we want to say why. Go ahead and pause the video and take a few minutes to work on that.